All right, so here we have a little review of Unit 2, Sections 2, 3, 2, 5, and 2, 6 for our test coming up. And here we're going to go through the answers. All right, so first section here, we want to use this diagram to determine whether the statements are true or false, and we're going to justify using postulates. You don't have to necessarily remember the name of the postulates, but just need to kind of be able to explain those postulates. So points A, B, and L are coplanar. That's the first thing. A, B, and L. A, B, and L are coplanar. That's true. You can see they're all on plane K, but even more important than that, this is true because any 3 points are coplanar. So it doesn't matter where the points are, they're going to be coplanar. If I asked you about A, D, and F, well, you can see D and F are drawn over here on this plane. A is on plane K, but there is a different plane that's not drawn in that would go through A, F, and D. So any 3 points are coplanar, or any 3 points determine a plane, something like that. That's called the 3-point postulate. Okay, but again, just saying something like this is good enough. You don't necessarily need the name. So DE lies on plane G. Well, here's plane G. D is on plane G. E is on plane G. So yes, DE is on plane G because the 2 points are. So if 2 points are on the plane, then the whole line's on the plane. Now we got DF is intersecting AC. Well, DF goes through this plane. AC is on this other plane, and AC actually does not touch DF because they're on different planes, and you can see this dotted line means that AC is behind it. So AC is not actually touching DF, so that's false. Because they're on different planes, it's false. So how about this? D, F, and E are collinear. Well, D, F, and E are on the same line that's drawn, so yes, they're collinear, and because they lie on the same line, DE. So we might say that points D, F, and E are on lines DE there. All right, very good. So now we want to get into some proofs here. So here we want to prove that angle 3 and angle 2, well, we know, angle 3 and angle 2. Angle 3 and angle 2 are congruent. Let's make that congruent, actually. Angle 2 and 3 are congruent. That's given. Okay. Now we want to make our way down to say that they're supplementary. So we're going to need to get into angles. We want to say supplementary means they add up to 180. So let's make a plan. We know these two add up to 180. We want to say that 1 and 3 add up to 180. And we know that 3 and 2 are the same. So here we know that the two angles, 1 and 3 are supplementary, and 1 and 2. Okay, so they're both supplementary. 2 is supplementary to 1, 3 is supplementary to 1. So that has to be true because 3 and 2 are the same. So we're going to see some substitution, and let's see where we can go with this. So make that a 2. Can't count. All right, we got a 2, and so we know that the measures are equal. So we convert it into measures. Now we got an equation. So that's because they're a definition of congruent. In other words, that's just what congruence means. And so now we know that. Well, what else do we know? We're trying to get into the world of supplementary. We're trying to talk about 1 and 3, but when we're doing a proof, just start writing things down that you know. And we know something about 1 and 2. I don't know if it's important, but measure of angle 1 plus the measure of angle 2 equals 180. Okay, how do I know that? Well, they're a special angle pair. They're a linear pair. That's the linear pair theorem. All right, so the linear pair theorem tells us that 1 and 2 add up to 180. All right, so that's nice. Now we got 180. Now we're getting close to supplementary. We want to say 1 and 3 are supplementary. We got 1 and 2. So this 2, we wish that was 3. Well, can we replace that with 3? Sure we can, because 2 and 3 are the same thing. So let's replace that with 3 in step 4 here. measure of angle 1 plus the measure of angle 3 equals 180. What do we use? We just put something in place of something else. That's substitution. All right? So substitution tells us that 1 and 3 are the same, and well, that's basically what supplementary means. We're pretty much done, but we've got to go one more step to say, therefore, angle 1 and angle 3 are supplementary. And how do we know that? Well, that's the definition of supplementary. In other words, because they're supplementary. So that's because they add up to 180. If you want to put here because they add up to 180, that's fine. You don't need to write definition of supplementary. You can just say because they add up to 180. All right, let's go to the back page. Very similar proof here, just kind of flipped around. We've got our given. Always start with the given. That's an easy thing to do. First line, piece of cake. Given stuff. Given, that just means, hey, it's free. The problem told us that it's given. Okay, so we know that 3 and 2 add up to 180. We're trying to say that 1 and 3 are the same. So again, we're just going to look for things that we know to be true. You know, we notice linear pairs. Hey, that's important stuff. We can say something about that. We can say that measure of angle 2 plus the measure of angle 1 is 180. Okay? So we know that to be true. Why? Because they're a special angle pair. What kind of angle pair are these? They're a linear pair. So that's the linear pair theorem. All right? Now, we've got 3 and 2 make 180. 1 and 2 make 180. Well, if this is 180 and this part is 180, then these two things have to be equal to each other. Right? So measure of angle 3 plus the measure of angle 2 from up top is... Actually, I'm going to flip that around. Just thinking ahead here. Let's put the 1. Measure of angle 2 plus the measure of angle 1 is equal to, we know it's equal to 180, but so is the first thing. So that's equal to the measure of angle 3 plus the measure of angle 2. And what do we use there? That's the transitive property. Okay? Transitive property of equality. Now we notice we've got 2's on both sides, so we can subtract those things. And we're left with a measure of angle 1 equals a measure of angle 3. Once we subtract them, and you don't have to show minus 2, minus 2. Okay? We're subtracting those two things. We're left with the middle stuff, and that's what we're looking for. Why did we get that? That's subtraction property. Okay? On to the next one here. We got our vertical angle theorem. We're going to prove this. You can't use vertical angle theorem as your reason. Okay, we're told that 1 and 2 are vertical angles. We want to show that they're congruent. Okay, we can't say, I know they're congruent because they're vertical angles. We already talked about that. No, you can't do that. Okay, so we have to go through the steps here and prove it. So, how do we know that 1 and 2 are vertical angles? Well, that's given. Okay. And now what we got to do is we got to just remember what we did to work around. We know some things about these angles. We can use any other theorem, just can't use a vertical angle theorem. Well, what do we know about 1 and 4? Well, measure of angle 1 plus the measure of angle 4 equals 180. And that's because of their linear pairs. Okay. And what else is true? Well, 4 and 2 add up to 180. So 1 and 4 add up to 180. And then 4 and 2 add up to 180. Okay? So let's go ahead and say measure of angle 4 plus the measure of angle 2 equals 180. And that again there is the linear pair theorem. All right, so 1 and 4 add up to 180, 4 and 2 add up to 180. So if they both add up to 180, they have to be equal to each other. Okay, so that tells us that measure of angle 1 plus the measure of angle 4 is equal to 4 plus the measure of angle 2. And what do we use there? Just like up above, the transitive property. Okay. And now, last but not least, if we subtract 4 from both sides, we get measure of angle 1 equals the measure of angle 2. And we just did some subtraction property. Okay. And then, last but not least, our proof asked us to say they're congruent. Well, now we can say that's congruent because that's what congruence means. That's the definition of congruence. And there you have your proof of the vertical angle theorem. We never have to prove that again unless we're asked to on a test or something. Okay, but now we can, anytime we have angles like 1 and 2 that are across from each other, we can say they are congruent because of the vertical angle theorem, because we've already proven it. And so now it's always going to be true. There's how you do proofs. All right, get ready for that test, study hard, and we'll see you for the test day.